Hi students, now I will talk about question number 5. We have 3 bodies. The first one is 2 kilograms, the second is 3 kilograms, and the distance between them is 1.2 meters. The third one is 1.5 kilograms. It is on the left of the first object in a distance 0.8 meters, which is 80 centimeters. Be careful that the distance between the center of the first body and the second body, or we can use these bodies as point bodies, okay? The distance from 1 to 2 is r from 1 to 2, which is equal the distance from 2 to 1. So when we change the indices, it is the same. Also, the distance from 1 to 3 is the same from 3 to 1. The distance from 2 to 3 is the same as distance from 3 to 2, the direction. Now we have forces, which are the gravitational forces. The first object attract the second one in this direction. The second one attracts the first one in this direction. The first one attracts the third one in this direction. And vice versa, the third one attracts the first one in the negative x direction also. The third object attracts the second object in the negative x direction. The second object attracts the third object in positive x direction. Okay? Now, as you learned from the lab section, if I need to find the force from 1 on 2, it is F from 1 on 2, F1, 2. This is F1, F1, 2. This is F2, 1. This is F from 3 on 2. This is F from 2 on 3. It is just a name. Okay? Now, I need to calculate the force between the first body. I didn't go yet. I didn't start yet by A, B, and C. I just need to calculate the force for each body. The force from 1 on 2 is equal to. Also, you need to note that all the forces are attractive. Okay? We need to know also the direction for each force. The first force from 1 on 2, it is G multiplied by M1 multiplied by M2 over the distance between R from R1 from 1 to 2, R1, 2. Okay? The force from 2, this force is in negative x direction, to this direction. Okay? The other force, F2 on 1, F2, 1 is equal to G, M2 now, not M1, M2 multiplied by M1, the acting mass, the interacting mass over R2, 1. It is the same, just we change the masses and the distance is the same. G is known, G is equal to 6.6 multiplied by 10 to minus 11 or so. Okay, so the first attracting force from 1 on 2 is M1, M2 is 2 and 3, 2 and 3. The distance 1.2 meters squared is equal to 2.37 multiplied by 10 to minus 10. E minus 10 newtons. It is very small. Also, the force from 2 on 1, F2, 1 is equal to G, the same G. This is 2 and 3. This is 3 and 2. And the same distance. It is the same answer, the same force. But the direction of this force is opposite. with direction x positive. Okay, this is because of the third Newton's law. Okay, now the forces between the first and the third object, the same way, it is equal to G m1, force from 1 on 3, m1 and m3. The distance between 1 and 3, this is the distance, r13, which is equal to r31, which is 0.8. We need it squared. This will be equal to 3.13 multiplied by 10 to minus 10 newtons. This one is the same as 10 to minus 10. Okay, the direction of this force to the positive x direction, this mass act on the third one and attract it to this direction. It is to the positive direction. Now the third mass is attract without is to this direction, to the negative x direction. So F from 3 on 1 is equal to G m3 m1 over r31 squared. The same magnitudes, 2, 1.5, 1.5, 2. The same distance, it will be the same force and with opposite direction. Okay. Now the forces between F2 and on 3 and F3 on 2. We use the same G, which is a universal constant in our study, multiplied by m1, m3, m2, m3, m3, m2, the same distance. Then we have the force, in this case, the masses, the distance. The distance here is 1.2 plus 0.8, which is equal to 2. The distance between the second and the third mass. Okay. So the force is equal to 7.5 1 multiplied by 10 to minus 11. This in to the positive x direction, F2 3, and F3 1 2 is to the negative x direction. In this case, I find the force between two bodies. But what if, as required, A, B, and C, what if I need to calculate the total force on the first object? The first object under the interaction between the second one and the third one. And look, we have the forces on the, this is it. This is the first object. We have the attractive force between the first and the second, and the attractive force between the first and the third. This force with the second object to the positive x-axis, and this one to the negative x-axis. So this is positive and this is negative. We need to suppose a positive direction and negative direction. We have two forces, and the force, as we know, is a vector. It is simple. It will not be difficult because we calculate everything. So the total force on the first object is the summation of the forces. Because they are in the opposite directions, then we can take the positive minus the negative one. F21 minus F31. We calculate each one of them. F, the interaction between the first and the second, is 2.37 multiplied by 10 to minus 10 minus 3.13 multiplied by 10 to minus 10. The answer is negative 0.76 multiplied by 10 to minus 10 newtons. The negative sign means the direction. The direction is to the negative x direction, because from the beginning we take the positive x direction is the positive sign. So negative means in negative x direction. So the total force on this first body is to this direction. Okay, the second object is under two forces, and both of them are from the left, from the first and the third body. So we need to add them together. But we need to know the direction because both of them are in negative direction. So we can put this negative and this negative, and all the result is negative. The negative means in the negative x direction. So we need just to add f12 plus f32. This will be equal to, we just solve all of them. We just need to add each one to another one to find the total force on any object. This is the total force on the second object, which is in this direction. The third body, all the forces to the right, to the positive x direction. This is to the positive x direction, and the forces from the first object and the second object. We just need to take them from the first and the second. This is the first and this is the second. Add them together, it will be 3.88 multiplied by 10 to minus 10. Now, the final interacting system, in this system, the first object has a force between it and the second one. Okay? And the second and the third have these interacting forces. Okay, and between the first and the third, this is interacting force. Okay, this one. There is no any external force. The system is closed. The total force should be equal to 0 because the third Newton's law, each force has opposite force with the same magnitude and opposite direction. Look at this one, negative 0.76, and this one, negative 3.12. Add them together in negative sign. 6 with 2, 8. 7 with 1, 8. 0 with 3, 3. In positive. So the total positive forces is equal to the total negative forces. In this case, we've solved A, B, and C. Now we need to go to D. This is a long question, but it is okay. Now, what if the first object doubled its mass? So the mass is not 2 kilograms, it is 4. The third object reduced its distance from 0.8 to 0.4. So R13, it is not equal to 0.8. It is equal to 0.4. What is the total force on the second object? This one. The total force, as we solve it here, I will not solve in this shape, but I will use that the total force to the left direction from the first one, we have the force from the first object on the object number 2, from 1 on 2, and we have the force from object 3 on 2. And both of them are acting to the left, yes, to the negative x direction. So we can add them together, and at the end we need to know the direction of this force. Okay, the first force is equal to G multiplied by the first mass, the second mass, over R12 squared. R12 is the same, 1.2. There is no change on it. Plus the second force is G, M3 multiplied by M2 over R32. R32 now, it is not the same. It is not 2. Because it is from the beginning, it is 2. Now this object comes to this place, 0.4. Then the distance between the third and the second object is 1.6 now. A new distance squared. And the total force in this case is equal to 6.3 multiplied by 10 to minus 10 newtons to the negative x direction. If we look at the force initially, it is 3.12 multiplied by 10 to minus 10 to negative x direction with this minus sign. We can put the minus sign, it's okay. But minus sign means that direction. We know the direction, it's okay. So the force is raised now because of two reasons. The first reason, this mass is raised. The second one, the distance is reduced between the second and the third force. This is the part D. Now let us go to part E. It is the same. We need to change some parameters. So the first mass was 2 at beginning. Now we need it halved. Okay, it is 1, not 2. The second mass, it is not 3 now, it is 6, it doubled. The third mass, it is not 1.5, it is 4.5, which is tripled in this case. And we have the distances are the same. We don't have the change in that distance. We need the total force on the first object. The first object has two forces in opposite sides. Okay? The first force is from the second object. The second force is from the third object. We need to take this minus this. F2, 1 in positive direction minus F3, 1 in negative direction. We need just to put the formula for each force. G M2 M1 R21 squared minus G M3 M1 R31 terbiع squared. I'm sorry. Okay. Now just use them. G is a constant. You can find it in this calculator. It is. You can find that on constant. There is a built-in constant, and all of them are for physics. Okay. And the force with the negative sign between the two forces is negative 1.9 multiplied by 10 to minus 10 in newtons in negative x direction. So in this case, this mass will win. The third mass will attract the first mass more than the attraction from the second mass. Okay, this force is stronger than this one. Okay. Now, part F. What if the first mass is doubled? It is not 2 now, it is 4. The distance between the first and the second mass, it is not 1.2. R is not 1.2. It is halved. It is 0.6 meters. This is the mass number 3. Changes its place. Okay. And the third mass tripled its distance from it. The distance is not now 0.8, it is 2.4. It is multiplied by 3, and it is the same magnitude, and the mass number 2 is the same magnitude. So we need the total force on the first object. In the same way, the first object has two forces in opposite directions, the positive one minus the negative one, and we will see now which one is stronger. So we just need to put the new numerical values. M1 is not 2, it is 4. The distance is not 1.2, it is 0.6 squared. Be careful by that. I think it is exists in the exam. I forget that, but be careful about that. And I mean this trick, doubling and halving and tripling, maybe it is exist in the exam. It is just a numerical processes. Now the mass M3 is 1.5, M1 is 4, the distance is 2.4, not 0.8 as it was. So the total force on the first object now is 2.15 multiplied by 10 to minus 9 to the right because it is positive. Now the force from the second object is stronger than the force from the third object to the right. In other language, this mass, the first mass, will accelerate to the right. We can compute the acceleration. Just we have the force, we have the mass. We can find the acceleration. Okay? Now, what if we have... Now we have important parts. Please pay attention for this. We have the first mass, the second mass, the third mass. What if we have another mass, a new one? I name it, and this mass is 6 kilograms. I name it M6 because it is 6, which is equal to 6 kilograms. And I don't wear its place, but I know that it is on the right from the second object. Why? Because I need the force on the second object is equal to 0. I need the total force on the second object is equal to 0. And we now have the original example, which is in the first part. We have the original one, A, B, C. We don't have any changes on the displacements or in the magnitude of the masses. We have the original as we always do. Now we have the forces from the first and the third object on the second body. We have the first and the third forces to the left. We need, and the force on the second object to the left is negative 3.12 multiplied by 10 to minus 10 to the left. What if we need this force to be 0? We need another third force to the right with the same magnitude of this, with positive sign, and the total force at the end will be 0. So we need a new force which is equal to the forces to the left from the first object and from the third object. And we need this force, the source of this force is the existence of this mass. We need this mass. Because of that, we need this mass to the right of the second object. So we have F from 6 to 2 on 2 to the right. So this new force is F62. F62 is equal to, now F62 is equal to F12 plus 1 F31. 32, I'm sorry. 3 on 2. And this one also is 3, 2. I'll change it. Okay. On 2. Now, F12, F32, these are the formulas. It is easy. F62 is G, M6 and M2 over R62 squared. But we don't know R62. We need to find this distance. From B, part B, we find that the force is negative 3.12 multiplied by 10 to minus 10. But it is in the negative x direction. This is it. We need it to equal to the new force 62. But this one is to the right. G is the same. It is constant. The new mass, M6 is 6. M2 is 3. It is the original mass. And the unknown distance R62 squared. In this case, just we need to reorder this formula. Then R62 squared is equal to G multiplied by 6 multiplied by 3 divided over this magnitude. It will be 3.4 meters squared. Because R squared, this meter squared. Now, R is the root of 3.4. okay, which is 1.844, approximately 6 meters, maybe 2 meters, I'm sorry, but it is 1.8 meters, okay. So we need to put 6 kilograms away from the second mass to the right, 1.844 meters, okay. Focus on that. Repeat this part more than one time, you will understand it. But the basis of this is the simple these parts in part A and B and C, okay. Now also we can do this process. The forces from first and the third object. This is F1, 2. This is F3, 2. This is F6, 2. This is F1, 2, F3, 2, F6, 2. It is easy. G M1 M2 over R1 2 squared plus G M3 M2 over R2 3 2 squared is equal to G M2 M6 M2 over R. Because we have M2 in all the terms, we can cancel it. It is a constant in each term. We can cancel it. Because we have the constant G in each term, we can cancel it. So we have M1 over R12 squared. This is it. M3 over R32 squared. This is it. M6 over R62 squared. This is it. In this case, these values are these. 6 over R62 squared. So R62 squared is equal to 6 over this value, which is 1.7639 and so on, which is equal to approximately 3.4 meters squared. And the root square of this value is equal to 1.8. Be careful that maybe if you approximate and you remove this quantity and this quantity, you will have a change and different values, but in general it is the same way, and the values will not be differ in a huge amount. But later you will see it will be different. Now H, we have the first, the second, and the third object. We have the third object. We need to put another mass on the left of this third object, as we done before for the second. This distance is known now. It is 0.4, but we don't know the mass. Before, now we don't know the distance for the sixth object. We don't know the distance, but we know the mass. Now we don't know the mass, but we know the distance. It is the same way. We can use that because we need an equilibrium on mass number 3. F4, 3. I name this M4, okay? So the force from the fourth on 3 is equal to the forces from the first and the second objects on the third object. I know these values from the first part of my solution now, but I use the second way now. Look, the force from 4 on 3 is equal to G M4 M3 over R4 3 squared. The force from 1 on 3 is G multiplied by M1 M3 over R1 3 squared plus F2 3 is equal to G M2 M3 over R2 3 squared. Okay, M3 now is common in all the terms. I can cancel it. G also can be cancelled. Okay, so I have M4 over R4 3, M4 over M1 over R1 3, M1 over R1 M3. The same distance is from the, okay, there's no change. We have the original question. The second mass is 3. The distance from the second and the third is 2 meters squared. Then the mass number 4 is equal to 0.4 squared multiplied by this value. This value is this. Just I simplify the solution by step, okay? Now this will be equal to 0.62 kilograms. So M4 is equal to 0.62 kilograms. We have just one unknown variable. Maybe it is the mass, maybe it is the distance, maybe it is another mass or something like that. Please repeat this example many times to be understood. The simple steps is just to find the force between two objects. Then we need to find the resultant force, which is a vector, on an object by two objects. Okay? And good luck in this. Thank you.